Hey everybody, Mr. Roberts at Castle Hill Country Day School, and this is going to be the first of what I hope are many really fun activities for you to do at home while we're waiting to get back to school, hopefully in a couple of weeks. Today we're going to be making something called sodium acetate. Sounds like a big word. It's not really complicated. All I'm going to do, I'm going to combine a little vinegar and a little baking soda. We're going to add some energy to it, and we're going to make something new. Now, before I begin, a little bit of review. Okay, what is matter? Anybody? Oh yeah, you in the back? Excellent answer. Anything that takes up space and has mass is matter. So basically everything. This funnel, all the air in our classroom, all these things behind me here, this eggshell, it's all matter. It takes up space and it has mass. I can feel it. There's some weight to it. Now, how can matter change? Anybody out there? Oh, yeah, you in the back. Perfect. Yes, the first way that we can change matter is a physical change. All right, so if I take this marshmallow and I physically change it, I can pull it apart, I can make it all sticky and gooey, but I'm not changing any of the little marshmallow atoms, all those little marshmallow atoms that are bonded together to make this marshmallow. All right, it looks different, and it might even look a little yucky, all right? But these marshmallow atoms have not changed, and they still taste just as good as when my marshmallow looks like this. Okay, the other way we can change matter is chemically. And when we do that, we're going to change these little marshmallow atoms, everything is bonded together inside here, and make something new. Now we know a chemical reaction is taking place when heat is given off, when maybe bubbles are created, when there's a change of color, or when a solid is created when we add two different things together. Now once that change happens, there's no going back. Now if I change this marshmallow, the atoms in this marshmallow, if I change them chemically, they're not going to be marshmallow atoms anymore. So of course, we need to do that, don't we? So, I got my little campfire here, and I got my marshmallow, and let's cause a chemical reaction. I can already see there's some bubbling going on, so I'm applying the heat. And my marshmallow already, you can see a color change. Smoke. All right, that's indicating some kind of change there. Yum. All right, now we're really cooking. You can see, I'm gonna blow this off right now. All that black stuff, okay, that's just caramelized sugar that the marshmallow was made out of. But it's no longer sugar anymore. These atoms are all changed, and actually the outside crust of this stuff, it looks almost like ash or dust. We can call that carbon. Okay? Now, if you like to eat burnt marshmallows, all the power to you. But I'm going to leave this one for later. All right, let's get on with how we're going to make this sodium acetate stuff. Sodium acetate, after we make it, we're actually going to have a liquid that we're going to then cool down very, very low. And it's going to stay a liquid, but as soon as we disturb the atoms that are in that liquid, they freeze. Okay, so it's almost like a liquid turning from a solid right in front of your eyes. All right, so the first thing we're going to do is got a measuring cup. All right, and I need 1 liter of vinegar. Okay. Now, if you've got your normal cups at home and you're using I guess the American system of measuring things, you're going to use about 4 1/4 cups cups, that normal measuring cup that your mom or dad have, or we can pour it into our measuring cup here that has liters. Now, if you don't have one that measures liters, you can also find a soda bottle. And you'll see on the outside here, it says 16.9 fluid ounces, or 500 milliliters. Fill this thing up twice, and you're going to have 1,000 milliliters, or 1 liter. So I'm going to finish pouring this up. All right, there we go. 1 liter, 1,000 milliliters. And I'm going to pour it into this bowl here. Okay, so far so good. All right, we got our liquid. The next thing I'm going to add is 60 milliliters of baking soda. Okay, now this is 15 milliliters. And most cookbooks in America would call this 1 tablespoon. 15 milliliters. I'm going to go ahead and... Now, what do you think's going to happen when I pour my baking soda into the vinegar? You're right, we're going to get a bit of a reaction. Okay, I'm here with my very... Quiet down! Shh. I'll send you to the office. I've got my reaction. Quiet. Okay, if you do that one more time, I'm sending you back to your class. I don't think Miss Mattingly's going to want to see you. Okay. So I got 1. 2. Now I'm doing these just one at a time. If I were to pour it all in at the same time, it would definitely go over the edge, and it's getting pretty darn close right now. So we got some atoms that are changing what they once were into something new, making new friends. Three. And 4. All right. It's kind of fun. 4. Okay, so once I have the baking soda mixed into the vinegar, I'm going to put it in a pan. All right. Now, I should have mentioned earlier, well, none of these ingredients are toxic, which means it could cause you harm. Could maybe irritate your skin or things like that. If you smelled a lot of it, it could maybe irritate your nose. But since we are using our stove and we're going to be getting this stuff pretty hot, probably be a good idea for your mom or dad or another adult in your house to help you out with this one. I'm going to pour this in. Okay, so that's 1 liter. Our goal with this is to apply heat. Okay, we're going to get those water molecules in there dancing all over the place, and some of them are going to evaporate. Okay, and while the water's evaporating, what's left behind is the baking soda and then the different, I guess, elements that make up vinegar are going to stay behind. So we're going to make a very concentrated solution. So we got 1 liter here. My goal is to apply enough heat that it's going to simmer until we only have about 150 milliliters left. All right, that's going to be about right there. All right, so this takes about, I don't know, 40 minutes or so. Now you don't want it to boil. All right, we just want to apply heat slowly. See, if we boil it, we could cause another chemical reaction, in which case our sodium acetate is not going to be sodium acetate. It'll be something different. So I got my heat on medium, and I'm going to let this cook for a little bit. I'm going to go back and work on some really fun 3D prints the 5th graders have been sending me, and we'll see what happens in a little bit. Stay tuned. Okay, I've been cooking our vinegar baking soda for about 10 minutes so far, and you can see some bubbles are forming. We got a little bit of evaporation taking place. The water is going up. It's going to turn into water vapor. Giving off a smell. It's not bad. I'm going to turn my heat down just a little bit here on the side. Just a little bit. And there's no rush with this. There's no rush. And actually, if it takes a little longer, that's fine. We just want to make sure we don't boil it down too fast. So let's all be patient. Okay, it's been about an hour and 20 minutes. And you can see my solution is much, much less now. You can actually see some crystals forming on the bottom of the pan. And I'm going to see how much I got here. I'm doing this all one-handed. It's kind of hard. Where am I? Okay. There we have it. 150 milliliters of my sodium acetate. Now, what we want to do, I'm going to cover it with saran wrap, and I'm going to put it in the fridge, and we're going to cool it down until it becomes super cool. That means that it's below the temperature of when it normally solidifies. Alright, so here's my solution that's covered with cellophane, and I'm going to walk it back to the fridge. Oh, wait a minute. Jerry wants to see what's going on. Jerry, we're making some hot ice. It's going to be really cool. Just give me about 20 minutes, and then we're going to see some really fun stuff. All right, now that we've put in all the hard work, we're going to get to watch this reaction take place with our sodium acetate. I've carefully taken it out of the fridge, and it's sitting right here. A little condensation going on. And all the crystals, I mean, there are no crystals in there right now, but they are so ready to form. And the way we're going to do that is we're going to take some of the crusted sodium acetate that was on my pan. Alright, I don't need very much. I'm going to go ahead and pour what I can scrape off of there into here. Alright, I put a little bit of the sodium acetate crystals that were on the bottom of the pan into the beaker, and we can slowly watch the crystals grow. All right, so my sodium acetate has all crystallized, but one thing it did not do, it should have given off some heat. It's an exothermic reaction which produces heat. an endothermic reaction needs heat in order to happen, but this would should have gotten warm, and it's still pretty cold. And I'm wondering if, you can see we got some liquid in the top there, if maybe the concentration wasn't high enough. That could have been, maybe I didn't let it cook. Should have gone a little bit longer. We had some nice crystals form, but it took a little time. Usually it's pretty darn fast. So what do I do with this now that it is all solid? Do I have to do all that work again just to have more fun? And the answer is no. All you need to do is put the sodium acetate, and here I have a small test tube of it, into some water, and I put it on very low heat, and just see it's just barely bubbling. And you can see this is already a little liquefied. So I'm going to let this melt, go back into a liquid state, and we'll try this again. I'm going to do the same thing with my larger beaker. I'm going to put it over on the other stove here. Got a little water in there. And we're going to melt this one down too. So let's see if we can't have some more fun. Okay, it's been a few minutes, and you can see my test tube, the bottom part has melted and liquefied. It's still got a little bit of solid there, so that needs to go a bit. And in my larger beaker, you can see it's pretty much clear now. I see a little bit of stuff at the bottom. So I'm gonna put this back in the fridge, gonna cover it with cellophane, and we're gonna let it cool down again. I'm gonna let this cook just a little bit more, and then I'll put it in the fridge as well, and we'll try it again. Okay, back for round two. We melted down our sodium acetate again and put it in the fridge. Now I'm going to tap in a little bit of the crystals. Let's see what happens. I'm going to give it a little encouragement. Let's see here. Well, we definitely had a solid form, and it does feel pretty warm on the bottom. So this is a much better reaction than we had the first time. Okay, and the last one. Try and milking this for all I can. I'm gonna drop a couple little crystals in there, and we are off to the races. And this one is much more dramatic. Think so, Beer? And right down to the bottom. There it is. All coming out. This one is definitely warm. All right, everybody, well, there you have it. We have our sodium acetate experiment. Hope you've enjoyed it. Now go have some fun. Bye-bye. Hey everybody, I wasn't super happy with the first experiment we did with that sodium acetate thing, so I decided to cook up another batch, and here it is, another day later, and you'll notice that not only I did another experiment, I got a new cast, And it doesn't have any names written on it, so I hope you guys get back soon so you can decorate this thing. Alright, so like we did before, I'm going to scrape some of the sodium acetate residue that's in this pan. I think part of the problem might have been with the first one is that just my pan was really dirty. You know, I cooked everything in there from walnut shells to popcorn, and so there might have been some kind of impurities that didn't cause it to a reaction to go as, you know, as pretty as I'd wanted it to. So anyways, I'm going to try it again, and we're going to take that liquid and we're going to turn it to a solid right before our very eyes. So let's go do it. All right, so here's my sodium acetate, and I'm going to take a little bit of the residue and I'm going to just drop it in. Okay, you can already see the crystals growing at the top. That is beautiful. Ooh, there's a long one that just shot down. This is much better than the first batch. I'm checking the temperature here. At the top we got 50 degrees Fahrenheit. In the middle it's 46. Okay, the last of the crystals are forming. Okay, so there we have it. Whoops. Oh well. I guess it wasn't as solid as I thought. But that's pretty cool anyway, huh? Oh boy, what a mess. Anyway, hope you've had fun. Bye-bye.